And we're going to discuss about the regular falsi method. I have given the step-by-step procedure over here. You would be able to understand it, but if you still want to follow up of what I'm doing, you can listen to my lecture. As usual, the first step, we take the recurrence relation which is given in the following, and we need to find out fk, fk minus 1, xk minus 1, and xk. Now basically these are the things which need to be substituted in order to find out the recurrence relation. So we're finding out fk. Fk is can be written as f of xk because it's an approximate root, and xk can be written as r plus epsilon k because usually xk is of the form r plus epsilon k. Hence we now expand it in the form of Taylor series. The same thing happens for fk minus 1. It's the same procedure. Now guys, I just want to explain one thing. You can neglect from epsilon k cube onwards because it's 0.0001. It's almost a very small thing, so you can neglect it. It doesn't really matter at all. Now I've written here a point that xk equals to r plus epsilon k, xk minus 1 equals to r plus epsilon k minus 1, and f of r actually equals to 0. Now we are substituting all the values in the recurrence relation. We have just did this particular procedure. By doing so with this, I want you to understand that f of r equals to 0 as we have already saw here. Now so we're going to put the same f of r equal to 0 in this equation now. Now on substituting this, we're going to get this. Okay, it's basically an equation without f of r. Now we're just proceeding. It's just a simple procedure. All right, nothing much. Now what you guys were supposed to do is that get f dash of r term by 1 factorial terms together and get f double dash of r by 2 factorial terms together, and by doing so you will get this follow-up step. F dash double dash of r is actually taken out as a common, and then from that, by the formula of a square plus b square, we get epsilon k minus 1 plus epsilon k into epsilon k minus 1 plus minus epsilon k. It's just a simplification process from now on. The same thing happens for f dash of r. It's taken out as common from that, epsilon k minus 1 minus epsilon k, and now epsilon k minus 1 minus epsilon k gets cancelled both in the numerator and in the denominator, thus leaving us alone with this term. Now it's written over there that you have to take an LCM. It's obvious that you have to take an LCM. Take the LCM and then you'll be able to get this term. Actually you obtain this term, and the positive and negative terms of epsilon k into f dash of r by 1 factorial actually gets cancelled. It's an obvious step. From this onwards, it's just a normal simplification. As you can see, apart from the terms which are cancelled, that's the term which is already over there, right? Not that difficult, isn't it? And again, when you multiply it inside, you get these terms. Just cancel out these terms and it happens over the same thing. Now what happens in the next step is we're taking f dash of r from the numerator as a common outside to the terms in the denominator. By doing that, you can see we obtain this particular term with f dash of r with a product of 1 plus f double dash of r by f dash of r into 2 factorial into epsilon k minus 1 plus epsilon k. It's obvious. Take this to the numerator. By doing so, you get an expansion of a binomial series, and you can expand it in the form of binomial series. By doing so, you get this following term. Alright, now as I have written it over there, 1 plus x whole to the power of minus 1 is of that formula. For a shortcut to make it much more easy for you all, you can just include 1 minus x, and from a plus 6 onwards you can just neglect it. Now That's what we have did, and that's what we have obtained this term. Multiply the given term into the terms which are inside the bracket, you'll be obtaining this particular term here. And as now I need you to understand, higher terms of epsilon k into epsilon k minus 1 need not be included, because when you do that, it's going to create a much more bigger term and it's going to create a lot of confusions. I've worked this out. It's not worth the time, believe me. So you can just neglect the higher terms of epsilon k and epsilon k minus 1. By doing so, you get epsilon k plus 1 to be less than or equal to epsilon k into epsilon k minus 1 by 2 factorial into f double dash of r by f dash of r. And that's what is all about this particular thing.